Wait, cool. Recording has started.
Good evening, everyone. Welcome, and thank you so much for joining us today for X-Camp's 109th Educational Forum. I'm so glad you're here. My name is Stacy, and I'm a member of the teaching staff at X-Camp Academy. Tonight's topic is one that I think may be lingering on everybody's mind for so long. AI can code, so why should our students still learn math and coding? It's a great question, and many parents are wondering whether the skills we've been teaching our kids still matter in this new AI-powered world. The answer is a sounding yes. And over the next hour, we're going to show you exactly why through a real conversation with our student, Zerui Brandon, and our coach, Sam Shen. Before we dive in, I want to make sure you scan the WeChat QR code on the left side of the slides, because we will be continuing sharing more resources like this educational forums, full information through our Seattle WeChat community group. So please add us if you haven't already. All right, let's get started. Let me just take a moment to introduce X-Camp for everyone who is joining us for the first night. X-Camp Academy is a Silicon Valley-based competitive programming educational institute serving students from grade 5 through grade 12. Our mission is simple: help students shine in the AI era. We offer highly personalized, rigorous instructions, the kind that actually builds the deep thinking that AI cannot replace. And the result actually speaks for themselves. Our students have collectively earned over 450 USACO certificate, many gold and platinum, advanced to the gold and platinum levels, and 50 students actually made to the USACO finalist, not only with algorithm competition. We also shine in those IOAI competition. We got 4 EGOI medals, 4 IOI medals, and 1 IOAI models. There are some of the most competitive computer science competitions in the world. And we're proud to serve the Seattle community from our Bellevue campus. And tonight I will share more about what we offer here locally. We'll play a short introduction video, and after that, I will walk you through our program offerings. Sam, can you play that video for?
Okay.
We are not hearing the sound. Maybe you do play the sound through the speaker.
How to do that? Let me see. Just something. Let me just quickly check.
Or we can skip this one.
Okay. Sorry about that. Yeah. Okay. What this is? Oh, that's because I need. Oh yeah.
Yeah, no worries. Yeah, we already shared the YouTube link. Welcome everyone to check it on our YouTube channel later. Yeah.
So let me walk you through the actual programs we offer here at our Seattle campus. And I'm excited to share that our curricular is exactly the same as our Bay Area campus. This is where we come from. So your kid gets the same word class instructions. We structure our curricular into 4 tiers designed to meet students whenever they are and take them as far as they want to go. Tier 1 is our weekly core algorithm classes. This is a foundation, and it's week by week, usually 10-week weekend program. The classes are happening usually from Friday to Sunday, and for each level, there are different times. It's completely online. This is where most students begin building solid algorithmic thinking week by week. Tier 2 is our 100 problems challenge and mock test series. The 100 problem challenge is a problem bank. It's like USACO official guide, but it's our collectively selected a problem set to help students to self-prepare for the bronze, silver, or gold level. Many use our problem bank actually can advance to the bronze level themselves. This is proven. The mock test class, however, it's a weekend class that's serving usually in the USACO season from September till March. Once students have the foundation from our weekly classes, this adds intensive practice through extensive problem sets and weekly mock contests with coach going through the solution. This helps students to develop real competition readiness, not just doing homework problems, not just template theories in the class. The third tier is the USACO on-site intensive camp.
Sorry. Sorry.
Or I can just walk everybody through it. So the third tier is our on-site intensive camp. This is our summer day camp running July 20th through July 31. That's our day camp. That means it's in the San Jose in the Santa Clara region. You have to pick up your kids every day. So if the schedule doesn't work for you, there is also a leaving camp. So it's a boarding program. The leaving camp, so you can send the kids to us at UC Santa Cruz, and it's a 12 days leaving camp. It's a fully immersive boot camp featuring 7 to 8 hours of daily highly intensive training. We focus on we want to make a big leap over the summer for students who are really determined to pass either silver, gold, or platinum level. It's a direct face-to-face coaching where the instructor will work at on an intensive daily basis, give personalized instruction for our kids, and develop the kids because they are living together. They create a great friendship together, and they find kids with the same mind, the same kind of ambitions during competitive coding. The final tier is a year-round program called USACO Candidate Master and Grandmaster program. It's our elite pathway. This is for students who are really motivated and they know really in a young age they want to aim for competitive programming. The entry is by assessment and interview, so it's very selective. We want to ensure we have a highly focused dedicated cohort. Students get personalized weekly training, exclusive materials, guest lectures from industry leaders, and a community of highly achieving peers. It accelerates students from USACO Bronze all the way up to Platinum. This program has both online and in-person theories. For the online one, students from any region can join as long as they meet the coach standard. In-person is now serving Seattle region as well as the San Jose region. We're aiming to open more in LA, New York, and Boston. And today I have some exciting news for you because tonight is actually a special night for our 1-year anniversary. So we're offering this triple celebration benefits. First, tonight's similar coupon code is 0614, giving you $50 off of any program enrollments. Doesn't matter which tier you choose. Second, for our current Seattle students, you are free to schedule a coach one-on-one coffee chat so we can have a chance to learn more about your learning path, your goals, and your next step to see how we can better serve your personal goal. And this is completely free. Thirdly, we're hosting a free in-person trial classes on June 28th in Bellevue. If your child has never tried X-Camp before, this is the perfect no-pressure introduction to just get a feeling of what X-Camp platform, what X-Camp teacher, what X-Camp material is going to like. And finally, we are upgrading our referral bonus. So if you're a current Seattle student and you're referring a friend within our time window, we can give you both discount code, and we're upgrading that discount from $50 to $100 off. Both of you get this discount. and all the discount dimensions can be combined. So this is a great chance to actually enroll or try X-Camp's all tier classes. I will give the platform to our X-Camp students, Zerui, Brendan, and our coach Sam. So Zerui is actually our student 10th grade right now in Lakeside School. He was once the X-Camp Grandmaster Program student. He made to the USACO Platinum division, very selective. Only a handful of students actually made to this division. And my second guest is Brendan. He's now a freshman, also in Lakeside. He also made to the USACO Platinum division and qualified for AIME 3 times. Very good and impressive achievement. We want to learn more about how they made it and how X-Camp helped them. And finally is our coach Sam. He's now at the Seattle region, is our actually USACO coach. He is the dad of 2 MIT students, was right now a software engineer, and he had 20 years experience in the tech industry. He will be providing the insight of how to maybe raise a MIT kids, or if not MIT kids, smart, dedicated, hardworking, while still open-minded kids in this AI era.
Okay, let's get started. So the first part is about AI and how it relates to thinking. So the question 1 is who benefits and who struggles? What kind of students benefit most from AI tools and who might actually struggle more? I guess I'll start by answering this question. So I think, especially when you're just starting learning, using AI and relying on that is going to really decrease your problem solving ability, since you're going to begin relying on AI too much, and especially when you're beginning to develop these skills, having AI do all that for you is not going to be beneficial. And that's not saying that if you have already built up these skills, you should be using AI. Using AI really just takes away from the thinking part. And I think that it's very important for people to continue developing these thinking and problem solving skills. Zuri, do you have anything to add?
Yeah, I completely agree with everything that Brendan said. And after all, if we think about it this way, like a tool can be used, like any tool can be used in good ways or bad ways. It really just depends on how you use the tool. And personally, for me, I feel like the kind of student that benefits the most from using AI would be one that uses AI to learn the concepts, but then actually tries to apply the concepts and implement these concepts themselves. Since this way, you're actually building the connections between the type of problem and what it actually uses. And this is what helps, helps the student improve and helps them in the long run.
Yeah, definitely. Sam, do you have anything to add?
Yeah, I agree with what Zerui and Brendan said. I'm just probably speaking in a different perspective. Essentially, is because I think Zerui and Brendan basically share their like own like experience as a students, but as the educator, basically, we are thinking like just because AI can do this thing, but it doesn't mean it can replace the education. So from education perspective, students still need to like know things how it works. I think one of the uh, analogy is thinking about the calculator, right? Just because you have a calculator doesn't mean you don't really need to learn the arithmetic, right? Because you still need to learn those things. And also the other one is from knowledge perspective, everything built up like one by one, right? So you can't directly jumping, because without learning the elementary knowledge, you won't be able to understand the more advanced one, right? So AI will be benefit for people, have a strong willing to learn, and so I mean AI, the way I see is kind of like a amplifier. Essentially, it can speed up the learning, but it cannot replacing the learning process. You still need to go through that, right? So yeah, That's yeah. So for the people who struggle, I would say just like I think Brandon and Zerui already point out, if some students, if they say, "Oh, I just want to, let this one to help me to, to deliver the homework," those things, then if that's the only goal, then that's actually really really bad because the more you use it, the less you actually thinking by yourself. It kind of like the more you use, the less you actually learn. So and eventually you're gonna be, more struggle on that. Yeah.
Yeah, for sure. And then the second question is, what does over-relying on AI cost a student in the long run? I think we already touched on this a little bit, but when you're over-relying on AI, it kind of removes that thinking part of the process. And using AI to learn is very good, but using AI to, for example, do your homework is not going to develop these problem solving skills. And yeah, so if you're over reliant on AI, you're not going to be developing these skills. And also in competitions, you're not going to have access to AI. So you should still be solving the problems on your own, and you should really try to think through the process.
And also towards the other side of that, like implementation, like obviously we all know that AI can write code. So it's like there's also a bit of like whether you actually learn how to implement these data structures, how to be able to write these algorithms. Like in contests, you're not going to be able to use AI. You're not going to have the access to AI. So it's definitely also good to be able to think about how an algorithm is actually implemented, why it works, and bit of that. Yeah.
Yeah, one thing I want to add on that one, just like for example, for like the data structure, right? So learning like how to implement, how to use it, that's like like I consider that's the first step, second step, but the more important essentially is uh when to use it and what's the cost of using it, right? So, I mean, this is something which is I think it's very important. That's one thing I think is very different from the math and the CSS. Essentially, is everything you learn. One yes, there's no like one thing can solve everything. That's reason understand the trade-off is probably the key, particularly the one not just for the like competition. Eventually, for example, when you actually in the work, you need to understand everything has a cost, right? So every algorithm, there was a particular scenarios it was designed to do it. Every data structure, there was a particular thing it can solve in particular problem. The the context, the trade-off, the cost is actually would you need to understand that, not just say, oh, I can write code to do this. So yeah.
Okay, that's really valuable information. So now question 2 is, why does thinking still matter? AI can write code now. So what is a student actually missing if they skip the thinking?
So if a student so I'll start, right? If a student is using AI to write code and like do the actual thinking process, then the student is, like I said before, they're missing out on being able to connect these core ideas. They're missing out on just having the they're missing out on spending the time to debug their code, like why it's wrong, or just like actually practice what they've learned. So not only are they just honestly wasting time, they're also just wasting an opportunity for themselves to learn and grow. And Brendan or Sam, if is there anything you would like to add?
Yeah, I completely agree. And also, like later down on in the road, when you go into like industrial jobs, AI is not going to be perfect, and you're going to have to learn the skills for how to fix the code that AI generates. By so it is still very important to write the code by yourself and not rely on AI completely to do that for you.
Yeah, I completely agree with what the survey and the Brandon said. I just want to add one more thing. Essentially, say like think about but think about the why you want to learn the skill. Essentially, is you eventually is like the you need to figure out what the kind of problem you want to solve. I mean, I don't think that's something AI can actually because AI can solve a problem, but right now we don't see AI can proposing problem. right? Particularly for human, like eventually we want to, solving the problem we actually care. We can use AI to help us do that, but eventually you still need to figure out what kind of problem. But you know, this is kind of like more important than, so if without those skills, you may not even be able to identify the correct problem to solve. So yeah.
Yeah. And then secondly, AI amplifies thinking. It does not replace it. What does that look like in practice?
Yeah, so I can answer that. To start with like a personal example, like sometimes in 603, we have a lot of these complicated algorithms, data structures, and honestly, you're not able to, or like me personally, I'm not able to fully understand what we cover in class. So sometimes I rely on ChatGPT to be able to maybe like help me guide me through exactly maybe how some function of a data structure is implemented, or exactly why this mathematical theorem works. So in these cases, AI can actually be useful. It's like helping you guide the thinking. It's like helping lead you to realize why something works the way it does. And this is just like a personal example that I have. Of course, there are many other ways that AI can help you help amplify thinking, which I'll turn to Brendan and Coach Sam.
Yeah, I also use ChatGPT in that way to help reinforce what I learned. And another way that I use AI is sometimes I'm kind of stuck solving a problem, but I also still want to use the thinking process and not just look at the solution directly. So one way that I use AI is that I can just put the problem into ChatGPT and ask it for a hint or like one line from the solution. And using that hint, that allows me to kind of get closer to the solution idea, but it does not reveal the entire solution to me. So that way I'm still thinking through the question and I'm still practicing these skills and thinking.
Yeah. Yeah. So I think from the teacher perspective, I'm I I talk to all my students basically say like you can asking help for well for example like just before the AI, right? You can like asking help from your like parents, your friends, your teacher, if you get stuck or something, right? So but the key is just because they helped you doesn't you still need to understand to make those things like you know make sense to yourself. So those things eventually become your own understanding, right? So this part is still you need to proposing, you need to processing that, right? But well, but I mean with AI, it's more like there was something there like 24/7, right? So because a lot like before, maybe you can't really reach to a teacher all the time, right? So I think that's kind of so I was using that as an analogy to tell the part which can actually help you and which there are some part which is still not changing, right? So the part can help you is it can be there anytime, but it's not changing even if it help you, you still need to process it by yourself to convert it that one eventually be your own understanding. Yeah.
Yeah, I agree with that. Okay, now let's move on to the second part, which is learning math. Learning math and CS in the AI era. So the first question is, of course, when and how do you start? So how should students at different grade levels start? Go deep on one first or learn both together? So my opinion is that especially at like lower levels, directly learning how to code is pretty hard since coding relies on some basic mathematical principles, and it's also a lot harder for someone to learn, say, a language. And compared to math, like it's a lot more accessible, and there's so many more problems online that you can use. So my opinion is that you should use math as a starting point to get these problem solving and to develop problem solving and thinking skills. And somewhere around like fifth grade, you can start learning about coding and competitive programming. And the shift from math to coding is actually pretty, it's not that big of a leap, since a lot of coding problems can be solved using a mathematical framework. So by learning math, you are directly helping learn coding. And of course, it is important. Both of these are important, but my opinion is that math is a lot more accessible and a lot easier to get started with. So I think it's a lot better to just first do some math and then later on incorporate coding into the education.
And I completely agree with what Brendan said. Personally, I am not good at math, like that great at math. I think my AMC scores obviously reflect that. But like when I started coding in the summer before seventh grade. And basically back then, right, like I knew that I wasn't particularly interested in math, but I was introduced to coding. So I was like, okay, I saw that X-Camp was like an academy that like existed, right? And I was like, okay, sure, let me try out their 100 problems. And that was initially how I started to learn how to code and how I got introduced to various algorithms. And personally, now like that's how I just like slowly progressed from bronze to silver, gold, and then now platinum. But now that I'm in platinum, I realized that math is still a really crucial part of programming, like especially when we're learning more complex algorithms. Math becomes a really big part of like the base for these algorithms. And I find it sometimes a bit harder compared to my peers to understand these algorithms because I'm missing these like mathematical insights. So, like Brendan already touched on this, but definitely I feel like having a good, like solid fundamentals of math is really good. And this way, you'll be able to, like when you transition to coding, it'll be a lot easier. And I've seen like a lot of people close to me, like good friends who are very good at math and they transition to coding and have a pretty easy time being able to solve questions. And
Yeah, okay, I can add a little bit on that. So in my like I see a lot of students. I see uh kind of like different paths, but I think what Brandon and Zerui said in general is is correct. Essentially, is first is math CS. They help each other very well, and also I think uh, probably majority. I mean, big portion of the students they start math first, then they transition to the CS. I see the other way around as well, but eventually, like because just like Zerui said, like some students they start the CS, but at certain when they go to certain level, they personally feel a little bit the bottleneck. Then they gonna starting to pick up more math. So yeah, and also one more thing I want essentially is I think roughly in the elementary school, first is I think still the interest is the best teacher, right? So that's actually reason. For example, in the elementary school level, I see students are very different. So at that time, like if students, I mean, it's totally okay to introducing them from some stuff. I think at that time, from coding, most students start with a Scratch, right? Then Scratch, then they transition to the Python. So, but the key here is introducing them as an interest, right? Is let students to get interested, really like to do it. This is very important in the elementary level. In the elementary school, once they go to the the middle school, then you can start to a little bit more rigorous the training thing. So yeah.
Yeah. And then secondly, learning direction matters more than starting early. What does that mean? So I feel like what is kind of trying to get at is that like how you learn a particular topic is a lot more important than just learning something very early. Like for example, I've seen people who have started, say, for example, doing math at a very young age. However, the way that they're learning is not very efficient or good enough. And that kind of I don't guess like throws away, but it kind of defeats the purpose of learning so early. So I think it's a lot more valuable to get a good learning direction, well, rather than just starting early. And another issue with starting very early is that students, especially young students, may not have the interest in a particular topic, and forcing them to go in that direction very early is not going to be very beneficial. Rather, having interest and motivation to continue something is going to be a lot more beneficial and is going to help a lot more in the long run.
Yeah, I completely agree with everything that Brendan just said. And I think adding on to that, it just like Brendan said, it means like having the guidance and also just knowing like exactly at what point in your like I guess studying career you should like what you should be learning, right? Like let's say you are just starting out in bronze, you should not be like skipping to gold level topics, silver level topics. You should be grounded to the fundamentals of coding, the fundamentals of USACO. This way, when the later on you move, like later on when you reach higher levels, you'll be able to have these fundamentals to support you. And if you don't have a good solid fundamental, then at some point later on, you'll have to come back to these fundamentals. And sometimes it can be perhaps demotivating, or it can also be difficult, right? So I think like it definitely means just having these solid fundamentals, having the guidance, and just having the motivation and passion to do what you want to do.
Yeah. So just try to add two more things on this one. I totally agree with what Zerui and Brandon said. Just like two more. One is as I already said, like at early stage, interest is more important than the results. Then the second one, I think people tend to forget is in early stage, it's actually very important to establish a good habit. Like uh, but sometimes people just focus more on the result. But to be honest, at that stage, the result is not that important. You try to see whether you if you try to see whether you have any like bad habit and try to catch it earlier. That would actually help you do the wrong. And the other one, I think, for some like early, some students they start really early, but then they like demotivated at a certain point. I think one of the things I see is this is for any subject learning, right? So at the beginning, it's easy. It's like there's something called beginner's luck. Essentially, like you can probably learn very fast. Then you can see your progress. But at a certain, it doesn't matter what subject you're learning. At a certain point, you're gonna hit some difficult stuff. Okay, I think for the young age students, sometimes they mentally is not ready for handle the toughness, right? So the children, for example, like if they feel the difficult stuff, they say, "Oh, this is so." I mean, difficult stuff will automatically like you know demotivate the student, but that children you need a strong interest to overcome that thing to for you to continue going on that. To be honest, no subject will be easy. Every path, like it's all like at the beginning, it's easy. At some point, it's gonna be difficult. The only way for you to going through this bottleneck is strong, strong interest, good habit, persistent. All those stuff, all those like other like the uh thing would actually help you to go through that. Yeah. Um,
Yeah, I completely agree with that, and I've also seen that in my experience. And then the fourth question is how to avoid the AI crutch. I think we kind of already talked about this a little bit in part one, so we'll be talking about through this a little bit faster. But how can AI tools quietly become a crutch, and how do you avoid that? So I think in this case, like what crutch is kind of getting towards is like you're overly reliant on AI tools. And as we stated before, having too much reliance on AI is definitely not a good thing. And it can become an AI crutch when you kind of just always have ChatGPT or some other AI tool available to you to use, and you're always just checking. And like initially, it might not be anything too big. Like for example, you could be just asking for a little bit of help on a problem. But as you begin over relying on AI, it can slowly become more and more influential in how you think. And to help avoid this, I think it's very important to set some like guidelines to how you're going to use AI when you're doing problems. Like for example, for me, whenever I'm doing practice problems, I usually just tell ChatGPT to not give the full solution, so I can still think through the problem, and that also prevents me from over relying on it.
I want to approach this from, I definitely agree with what Brendan said, and I want to approach this from a different perspective, which is sometimes like what can lead to us like making AI tools become a crutch, right? Well, I feel like one of the most overlooked aspects is pressure. This can be pressure from your peers, pressure from your parents, and personally, I feel like obviously, me personally, I'm a very competitive person. Sometimes if I see like my friends are perhaps like solving questions a lot easier than I am, it can be really tempting to just pull out AI and help me, maybe I don't know, like give me a hint, maybe even give me the solution, right? But my suggestion is like really like slow down, take a break, think about whether AI, like this use of AI is actually helping you or not, right? Like like basically sometimes if you feel like this level of stress, sometimes it can be good to just take a break from coding or maybe talk it out with your parents, or maybe even just realize that this is good for you. Like you're learning something, which is good. You're going to be able to like slowly learn these like concepts, these like algorithms and stuff, and that will help you in the long run.
Yeah, I want to say what the Zerui just said. So, uh yeah, so in short, I would say like uh uh to realize learning is more important than the actual result. I mean, the result could be like, you need to finish this one, or you need to get a good score, in the contest, those kind of stuff, because it's if it's not if you're not truly like knowing it, you can take shortcut to gain some like benefit in short term. You're gonna pay the big price in the long term. Okay, just remember that. That reason, just don't take short term. So like get things that can help you, but you still need to make sure you really understand that. So yeah.
Yeah. And then also, what should students never outsource to AI when learning? So I think you should never have AI do the thinking or be writing the code, because that's very valuable and it's kind of how you're going to improve. And I think like during the learning process, it's okay to have some AI use, but I think it's still very important that you understand the concept fully without AI, since you are going to be the one that's actually going to be writing it down or implementing it in practice.
And furthermore, this like, I think personally, like from a competitive programming standpoint, who likes to debug, right? Like debugging can sometimes be really painful, long. The error may be like hidden in like some like very like obscure portion of your code, right? But you should never outsource debugging to AI. Like debugging, in my opinion, is perhaps one of the most crucial skills, and if you're outsourcing that to AI, you're definitely missing out on the ability to debug and also just an ability to recognize a mistake and learn from that mistake.
Yeah. So yeah, I totally agree with what the Brenda and Teresa essentially is thinking about the skill building, right? Skill building. You really need to like don't let the AI to take away the chance for your skill building. So because if they take away, then your skill is not built. So you will pay the price in the in the long run. So yeah.
Yeah. Okay, and now let's move on to part 3, which is relating what we've talked about so far to the real world and real world engineering and USACO. So what does real engineering look like? In a real software job, how much is coding versus problem solving? And how does math show up? Sam, do you want to talk about this?
Okay, sure. So this is a very okay. So I guess it's it's kind of like it depends on the job you're working on, but I would say uh mostly is the problem solving. Actually, before the problem solving was one more thing. Before the problem solving, essentially is proposing the problem, right? Because that's actually reason I think the proposing problem part, which is like AI, I mean, probably is not like so uh coding is just the way coding is just like the final thing, which is particularly, for example, from software engineering perspective, when you go from junior to senior, then go to architecture, you will actually find you will write less and less code. Uh, yeah, so you will basically you're starting off by like uh, implement a very small piece of the feature, then go to the whole services, and eventually go to the whole architecture. So uh, that's actually reason uh, I think uh, at any uh, you know from small to large, at any time you still need to understand uh, the for example why things work like that, and why when you design those meaning like a trade-off. In terms of the math, that also depend. Well, I would say, from software engineering perspective, like um, math, the way I see it is, it may not directly show up in your work, but it's actually uh, help you to develop the skill. Basically, is I think the key here when you learn the math is you're learning the abstraction. Essentially, is for the real world thing, like in order for it to become a solvable problem, you need to actually do the abstraction, right? Otherwise, there are too many like noisy factors there. Then to make the things is too complicated. It's almost impossible to solve. Uh, that's the one thing which is actually gonna help. The second one is uh, like in some I mean, in many company we are doing this like data-driven kind of the thing, which at that time, that's probably, you can actually directly apply your math skill. And also, of course, depends on the area you're working on, right? Some area probably gonna involve like more math, right? For example, like if you are working on the like AI, or if you're working on the modeling part, that's probably a lot of math. If you're working on like some other things, for example, uh, like the uh, image related, or like the video on the like 3D modeling thing. For example, if you're doing the gaming industry, then you then you build then those stuff a lot of math there. So, or for example, also if you're doing like the security related on the encryption decryption thing, that's also a lot of like a number theory related. So math in some sense is like everywhere. It just like depends on it really depends on area of the one you want to work. It's more or less the thing, but so I would say math apply on the two different angle. One is to help you to have a very strong abstraction skill. You can easily for you to help you to actually get the problem out properly. Basically you're modeling the actual problem, right? So the second one is depends on the area you're working on. Yeah. So something like that.
Yeah. Now let's move on to question 6, which is what does USACO really train? AI can generate USACO solutions. So what actually separates top students? So I think there's really two things that separates top students. Like one thing is kind of having the speed and being able to kind of produce these things quickly and having these ideas. And it's not even like too important. It's just being able to kind of come up with ideas on the spot. I think that's pretty useful. And also being able to generate a lot of different ideas. That's kind of going to be a lot more useful as we transition into an AI-driven world, because ideas are the one things that is going to be very valuable. And also another thing that is separating top students is having their creativity of their ideas. Um, Basically, all AI can do is pull from its training data and kind of look at past USACO problems and kind of look at their solutions. But top students are able to take a completely new problem or even beyond coding, a completely new situation, and they're able to still generate solutions and ideas for how to overcome that.
Yeah, I agree. I think Brennan honestly touched on like most of what I was going to say. Definitely like the ability to think creatively is definitely a key part. And honestly, one of like the stories that like have stuck to me the most was about this one camper who didn't know what binary lifting is, but they knew similar algorithms, they knew like how to think creatively, and in the end, during like camp selections, they were able to independently like to rederive entirety of binary lifting. So I definitely think it's just the ability to think creatively, ability to quickly apply these um, ideas and patterns that you've learned.
Yeah, I want to add that essentially is, yeah, creativity is definitely one of the things which I mean will be very, very valuable in the AI era, right? So and I think USACO like with the level going up, I think it will let the students to actually thinking deeper. Essentially, there's a the problem become more and more complicated, but you actually need to looking through you know, all the complicated, like the outside, you can, you know, you have a very deep insight on, what is the key, so this ability is, I think, is very important, particularly when you actually in the work, like, because once you go to work, the problem is undefined, it's very ambiguous, but who can have a deeper insight of the problem will probably get, deliver a better solution, right? So that's the yeah.
Mhm. And then secondly, even if a student never reaches platinum, is the training still valuable and why? So I think the training of being able to come up with ideas and being able to creatively come up with solutions to useful problems is going to carry through, and it's going to really help differentiate who's going to be successful in the AI era. And just having these skills is very important, even if the student never reaches platinum.
And beyond just like the training, I think like USCO, it's really also about the mindset. Personally through USCO, like I think I've gained a lot of resilience, I've gained a lot of patience, and definitely like even if you don't reach platinum, that's okay because honestly like it's the journey that matters. Like from all the way maybe from like bronze to gold, all the hours you put in, like maybe the resilience that you built up and the patience that you learn to have. This can also be really what separates a student from like modern day AI users because like are you willing to spend in the time to carefully work out an idea? Are you willing to be able to bounce back from failure? I think this is why like USCO training has really been valuable for me.
Oh, I want to second what the Zerui just said, the resilience. I think I see like you know I see okay. I know a couple of like they did really well in use. I think one thing in common. I'm not saying like okay how smart they are, but I think one thing in common is the resilience. It's like because the whole thing is not easy. I won't say this is easy. So you will probably facing the so-called failure, which is not really a failure. But I mean, if you failed, I mean, if you run the test doesn't work, you're gonna feel very frustrated, right? But the resilience will put you say, okay, I'm really I did terribly in the test in today, then I cry, but tomorrow I wipe up my tear. I go to practice more problem. You need that kind of attitude. I mean, sorry, a little bit off topic. So just like because just look like the New York Knicks, they win the NBA final, right? Look at the guy, he actually failed a lot of time. I think this is kind of the spirit that you need to be successful, not just in the coding, in your life, in your career, right? So, yeah. Oh, one more thing I want to say is this. Uh, I think so. USACO is about like algorithm, right? So one of the key things here essentially is for certain problem, you don't just produce the correct result. You want to produce in a faster way and also the basically less time, less space. Basically is uh, algorithm optimization thing. I think this problem gonna be there forever. Even think about this is one thing probably struck me in the last couple of months essentially is lots of people getting into the AI, but right now people didn't really asking the difficult question is okay, when I do this one, what's the cost, right? The token burning like crazy, right? So eventually people still want to come into here. So okay, if I want to achieve the same thing, how can I burn less token? I think from that perspective, the optimization thing will always has a place there, right? So so this is yeah, something actual, yeah.
Mm-hmm. All right, now let's move on to some opportunities to learn more about coding. So the first opportunity is at the X-Camp Seattle campus, as Stacy talked about at the beginning. For younger students new to coding, the Seattle in-person trial class will be held on Sunday, June 28th, 2026, from 1 to 3:30 p.m. for grades 4 to 6 students with little or no coding experience. Additionally, there will be a summer camp at the Seattle campus, which is another beginner-friendly option where students learn Python through creative projects such as digital art, animations, and interactive programs. Session 1 runs July 13th to 24th, and session 2 runs August 10th to 21st. Both sessions meet from 9 a.m. to 12 p.m.
And then,
What? This is not showing up.
oh, I think you click it again, maybe.
Oh, sorry. Oh, yeah. Okay.
Yep. All right. So we also want to take a quick moment to celebrate X-Camp results from the 2025 to 2026 USCO season. This year, one X-Camp student qualified for the EGOI US national team. 11 students were selected for the USACO training camp. And wait, Coach Sam, if you can click one more time, I think the second poster will show up.
Oh,
Yep.
that's the...
And two students from our 603 Grandmaster class, Jason Sun and Nelson Juan, qualified for IOI 2026. And we are especially proud that this marks the third year in a row that X-Camp students will represent the United States at the International Olympiad in Informatics. And these results reflect not only the hard work and dedication of our students, but also the strength of the learning community that we are building at X-Camp. So congratulations to all of our students on an incredible season. All right, so now let's move on to our summer camps. So first, we have our Bay Area 2026 Summer Day Camp. This camp is designed for students who are building their programming and algorithm foundations, especially those working towards USCO Bronze and Silver. The curriculum will cover Python foundations, core algorithms, and competitive programming problem-solving skills. The day camp will run from July 20th to July 31st. Monday through Friday from 9 a.m. to 5 p.m. Pacific time, and students can choose from different course levels of various difficulties. And this camp will be held at our San Jose campus, located at the address shown in the slide. Yep. Then probably next slide. There should be another camp.
Oh,
Yes. And then I think there should also be some posters that show up if click one more. Yep. Yeah. And then we also have, for our more advanced students, we're also offering the option of a live-in camp, which will take place from June 29th to July 10th at UC Santa Cruz. This will also be a great opportunity for you to meet our IOI qualifiers, Jason and Nelson, along with an IOI team member from New Zealand who will be joining us at this camp. So for students who are interested in competitive programming at a higher level, this is a great opportunity not only to train with them, but also to hear about their journeys, learn from their experiences, and receive valuable advice. And from my own personal experience, I've attended almost all of X-Camp's summer and winter living camps for the past 2 years. And I can say that these camps are a great chance to meet your classmates and peers, build friendships, and spend focused times improving at competitive programming. So if you're serious about growing as a competitive programmer, I'd highly encourage you to consider joining us this summer. And yeah, now we'll move into our Q&A session. And if you have any additional questions about the summer camps or anything, feel free to scan the following QR codes. Oh. Yep. So to start, we have a question for Coach Sam, which is how to define some bad habits from your teaching observations. What will you do when you find students have it?
so well, I give some concrete example, but because yeah, I mean the list can be very long and also really depends on the student, right? So I talk a little bit on the math side. I talk a little bit on the CS side because many students doing the math first. Then I think one of the biggest issue when students doing the math essentially is when they solving the problem, they never write any steps. You know, I mean, this is one of the issue which is also kind of like I think in the elementary, school probably that's not the requirement, but if you don't do that, it's posing a lot of problem because you only know the results, but you don't know because, as we say, the thinking process is more important, right? If you don't write steps, then there's no way for you and for the teacher to understand how you get here, right? Uh, there's also at early stage, let student to write steps is also a little bit challenging because they're gonna feel this is actual burden, right? They didn't really know this is required and this will benefit them from long run, right? And from coding side, there's a lot of it's kind of like tied to some of the software engineering bad practice. That's gonna be a lot of them. For example, when students come up like the variable name, they just put ABC. That's it's short and easy, but it's with no meaning. After like 1 week, you have no idea what this piece of code is doing, right? So um, yeah, so that's kind of what I mean by the bad habit. If I see that I'm gonna, well, for example, writing step is a little, I mean, depends on the student because some students you tell them they're just gonna try to, they even don't agree with you, they will try to do it, right? And maybe later when they feel the benefit, they say, oh yeah, that's I'm really benefit from that, right? And sometimes I'm trying to explain to them why that's bad, right? But so I mean, yeah, I hope that. Yeah, I hope that answer your question. So yeah, um,
Yes, thank you, Coach Sam. And then here's another question. How to keep passion during your coding or math study journey, especially since it's a long journey? Any tips? I guess like Brendan, if you want to start.
Yeah. So for me, there are kind of two different types of motivation. One is like more long-term motivation, and there's some more short-term motivation. So long-term keeps me continually doing coding. So for example, some long-term goals for me are to progress through USACO. However, these goals do seem a lot more far-fetched, and especially when you're beginning at lower level, it seems very hard to do that. So there's short-term goals are also very crucial in helping keep that daily motivation. Some examples for me are kind of setting some goals on Codeforces, which is another problem-solving site. For example, like having one problem solved a day, or just doing some contests on Codeforces and seeing how I do compared to my friends. So for me, I just have some goals and I'm kind of motivated through those goals to continue doing coding. And on the math side is kind of just I really love doing math and I just find it interesting. So that's how I keep on having that motivation. And yeah, that's motivation is really important in having continuing this continuing both math and coding.
Yep. I agree with what Brendan said. And for me, how I keep my passion is mostly like obviously as well, just like I'm really interested in coding, but I can't deny that there have obviously been times where I've received like really big I guess you could like quote unquote call them failures, and I like felt like I really want to quit. One of these times was last year. So before then, I was basically passing one division every single year, from bronze to silver, silver to gold. But last year, I was not able to go from gold to platinum. And after the last contest, I was really demotivated. But I'm really like grateful for my close like group of friends who were able to help motivate me and get me like into the right mindset. So definitely, I think like having these people around you to help support you when you're at your lowest is really beneficial, because like even if sometimes like these setbacks can really hit hard. um and then another question is for Coach Sam. How deep should the math knowledge be that we master in the AI era? Basic college level or deeper?
Oh, uh, I think that depend. Well, first is that's because when we talk about AI is actually a very large, like area. It's actually if you talk about okay, like for example, uh, depends on which part of the AI you're working on, right? I mean, you want to work on, right? So if you want to working on the core, like the modeling stuff, you probably need a lot of like a math. For example, but I would say like uh general the foundation one like linear algebra, like multivariable, then also the probability, because like these are probably the fundamental one. But if you want to go that's kind of like the fundamental for the further AI learning, right? Like then if you want to working on the modeling, you probably need more than that. But uh, but for you to just understand the general one, I think that the three course I just mentioned is the fundamental one. Um, yeah, yeah, I think that should be the on the math part. Yeah.
Yes. Thank you, Coach Sam. And here's another question, probably I think for me and Brendan, which is how do your parents help you during your math and coding journey? And Coach Sam, I think you can also like kind of talk about this from like a parent's perspective. And if Brendan, do you want, or Coach Sam, do you want to start?
Uh, okay. Uh, I I think as I said, like I want to well, as I said, like interest is like the best the teacher, right? So I think I'm trying to like first is introducing them as because I feel like this is interesting, right? So and also if they cannot accepting this is interesting, at least let them accept this is useful. So this probably gonna like motivate them like for the further learning. Uh, I share one thing on the so like so that's reason for math I'm kind of like say okay I try to say okay some of the things happening in the daily life there is some like mathematics stuff which is behind that, so sometimes I will actually talk about that. And from the coding actually, which is one interesting is I gave my daughter like cell phone when they are like like I think when they like middle school high school thing. So and I doing the like then I always like hear them complain, say, "Oh, this app really sucks. This app is not used. Here." So I say, okay. I say, then I think during when they like um so I kind of like lead them say, okay, if you think the app sucks, that's fine. I lead you to do a small project to build an Android app, right? So then okay. So they say, oh yeah, sure. I think the idea is start from something they are interesting, then that's probably will be easier to lead them to the one you want them to be interesting. I mean, that's kind of like from parents' perspective. Yeah.
Yeah, so from a student perspective, I think just having that motivation and having a lot of support from my parents was really important, and especially similar to Zuri's experience, I didn't qualify for USACO Plat last year, and just having that support from my parents was very important for me, and also having access to the resources such as X-Camp, and also like back when I was doing some more simpler musical stuff, my dad also helped teach some stuff to me, and that along with the resources from XCamp really helped reinforce my understanding of everything.
Yep. And my dad was the one that actually got me interested in coding because he used to like code as a software engineer. So obviously I already had that kind of influence. And when I was just starting out, when I first did the 100 problems for like pre-bronze, my dad would usually like take hours out of his day to just like help me understand these algorithms, help me understand how like to actually code. And some nowadays it's like he lets me know if there are any like summer camps or opportunities, and he just lets me choose whether I want to attend these opportunities or not. And he's also always just like there along with my mom to like help support me if I need help. And there's one more question for Coach Sam, which is, may I ask your kids' major in college? Do they choose by themselves or do you give them some suggestions? As a data engineer, what are your suggestions to current college graduate students?
Okay. Okay. Yeah. My daughter, their major is just math and computer science. I think it's well. I certainly give them some suggestion, but I mean they are old enough to make their own decision. I think this choice is kind of like the most popular in their school. So a lot of students in their school actually doing that. So yeah, that's probably and for the current college graduate students, uh yeah, I know I think uh as I said, like in the because I know like the background probably is because AI has a big like impact for the industry, and nowadays like many like CS students is really having a hard time trying to find a job. Yeah, I mean, uh, but my argument is I think AI actually impact not just CS. AI would impact every industry. So from that perspective, uh, this is now the time like you really should find your own like interest and your own passion, right? So like you can pick. I mean the reason is pretty simple. You can only do well if you really like it, right? If you don't like it, you are forced yourself then you're probably not gonna be excel on the one you on the one you are doing. So uh yeah, because of that, I would say like for any student, my suggestion is try to try to ask yourself what is your true passion really are, and and also embrace AI. I think every passion, every path, if you embrace AI, AI can accelerate your path. AI will not replace that. Trust, you should trust on that. Yeah, but you need to really have the passion and the interest on what you do. Yeah, that would be my suggestion. Yeah.
Mhm. And as we're almost out of time, this will be the last question. If there are any more questions, feel free to join the groups. We have all the QR codes up on the screen. Oh.
Yeah,
They should
sorry.
be on a green. Yeah. And then so the last question will be to Brendan. Are you still keep chasing the competitive level math? If so, how do you balance your time?
Yeah, so I'm still doing a decent amount of competitive math. And I feel like it does directly correlate to the competitive programming skills. Like for example, um, like especially in number theory and combinatorics, I commonly see these two topics come up in a lot of um, like high level like USACO plat both problems and also in like concepts that we learn in class. For example, the data structures and the proof of these concepts. Um, so yeah, I'm still chasing, I guess, competitive math. And I guess to help balance my time, I do spend a little bit more time on coding, but I kind of do try to get at least like 2 or 3 hours of math in per week during like school days. Of course, now it's the summer, I have a lot more time, but I do try to balance my time between coding and math equally. But doing one will definitely benefit doing the other. So there's, for me, there's really no, like, I guess I do both equally.
Thank you, Brendan, and thank you everyone for joining today. But I'll pass it off to Shanshan to help, or our X-Camp representative to wrap things up.
Yes, thank you, Coach Sam and our two students. Your sharing is pretty helpful for all of our students and parents. And if you have any more questions, feel free to join our WeChat group. And I would like to announce upcoming few more sharing session to everyone. We will invite our USACO finalists and the IOI US national team members to share their coding journey, especially in the AI era in a few July and August. So please follow our social media and we will keep in touch. Thanks everyone. Have a good night.